NAT on the 8.2. What we have done until now, dynamic NAT, we have done dynamic PAT, the one which you did yesterday, right? The one with the interface, use that interface IP to go out. Then we did the combo for both. Then we also did something where we translated when we said no NATing for this. We'll do that again today. NAT 0. It's not actually called identity NAT, it's called NAT exemption. Exempt this traffic from getting NATed. Yesterday I said it identity NAT, it's not identity NAT. Identity NAT is something else, which does the same thing, but in a different way. We'll see that today. Alright, so we'll revisit identity NAT. We'll start from here. We'll do destination NAT, identity NAT, policy NAT, DNS, doctoring, We'll also do something called static PAT. Let's do this here. We did this yesterday, right? So this will be the plan. Challenging topics, and yeah, one more thing. Where is there? And NAT control, identity NAT, or something called NAT control. Okay, so how many different types? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Total 10 kinds of different NATs. Same, sorry, not 8.4, this is 8.2. Same kind of NAT, you're supposed to do it on 8.4, but that's later. First we'll understand the concept, then later we'll go through and do the configuration on 8.4. Until then, it'll take you time to absorb the concept. Alright? The topology will be the same. What is it going to be? This is going to be my firewall facing the internet, but on the firewall I'll have some other stuff now. Now the internet, I'll do it a little differently. I'll have the internet facing down, right here, not 72. I don't need 72. R1, R2 will be my internet facing down. Hi. R3 will be on the side, one of the DMZs. R4 will be another DMZ. Let's keep it like this, so we know that PIX is the one who's facing the internet. PIX is facing the internet. To make it more interesting, let's have a serial connection. Alright, the PIX does not have a serial port, so we need a normal Ethernet connection. 1 goes here, 2 goes to the internet, 3 and 4.
3 and 4 are DMZ right now.
3 and 4 are DMZs. They were the DMZs yesterday also, it was just that R2 was on this side and 3 and 4 were up and down. Yeah. Okay? Let's turn it on. In the meanwhile, I'll go and try and get Bamboo. Exact same thing. Let's do one thing. Let's keep the record. Configuring R1. Right? Have a default route pointing towards the PIX. Also have a loopback with an IP address of 11. That's all. I'll create 1.1, 2.2, 3.3, all loopbacks on all these routers. Let's go to R2. IP address is This is R2. This is the internet. So 150.1.20.2. No shut. The loop back here will be 200 because this is the internet. No default route on this. That is the whole point. No default route back to the firewall. R3 is 3.3, right, with the default route pointing towards the firewall. Good. And a loop back 3.3. R4 4.4 4.10 with the loop back off. Done. My edge devices are set up. The only one thing left is the PICs. Interface Ethernet 1 is the one pointing towards R1. So security level is 100. Name if inside IP address is 10.11.11.10. Same like yesterday. Interface Ethernet 2 is the one pointing towards. Security level is 0 because it's the internet. So name if is outside. IP address is 150.1.20.10. No shut. Interface Ethernet 3 is DMZ3. So security level is 50. Name if DMZ3. IP address 192.168.3.10. No shut. And finally 4, right? Security level, let's say this is 49. I won't keep it same security, I'll keep it a little up and down, so I don't have to use that same security level interface, right? So name if DMZ4. IP address 4.10. No shut. Done. Show name if. Inside outside DMZ3 DMZ4. Good. This is simple stuff. I've done this a lot of times until now. My job is all of these devices should be able to access the internet. The PICs should have a default route to the internet. That is first exact thing, because if the PICs wants to go to anything 8.8.8 should be allowed to go. If he's not allowed to go, no one else will be. No one else will be. So let's have it on the PICs. Right now the PICs can't go if it pings on here. क्यों? There is no route to host 200.1. I'll need to have a route outside 00, and the next hop is what? 20.2. 20.2. 20.10 is me, 2 is the other guy. So now he should be able to ping. My ASA is allowed to. I'll do one. I'll come back to the. I'll do it very quickly what we did yesterday. Yesterday we had a pool of addresses here. The pool was 150.1.20.10 to 11 to 150.1.20.254. Let's say I only have until 20, only 20 hosts, only 9 hosts. I'll do that right now, right? I'll do that right now. I'll do it from from inside to outside. So this is inside. Right? This is my outside. This is the pool. This is the pool of addresses that this inside is going to use when it goes out. I want you to understand a little difference here. I want to teach you, the first thing I want to teach you is NAT control. Leave it there, don't want it there. We'll do this because we have done NAT exemption, so I'll also do NAT control. Right? NAT control, identity NAT and NAT exemption. There are two different things. NAT exemption and identity NAT plus NAT control. Right? Let's do that. Let's do that like we did it yesterday. How did I do this? How did I create a pool and used it? What was the first command? What was the first command for the pool? Global. Which interface? Outside. Then a pool number, say 10. Then the address 150.1.20.11 to 150.1.20.20. Then NAT inside to 10 and the inside addresses. I'll say 0 0. What does 0 0 mean? Everybody, anybody from inside should be able to use this pool to go outside. That means anyone from here, from inside, comes into here, tries to go outside, he can go. Right? Let's try. So R1 should be able to reach where? A little time to do the NAT translation. Should be allowed to go out. Open. R2, I will line VTY04, enable the password, enable telnet. So R1, when he tries to go out, is Cisco. He can go out. The one problem this had, okay, I forgot to do one thing though. Forgot to run a routing protocol. I'll run EIGRP everywhere. Network 1.0.0.0 auto R1 R2 के बगैर R3 R4 पे रन करूँगा. All my internal network will have a routing protocol, so I can share what my loopbacks. The same stuff I did yesterday, right? This right here. So I'll run a routing protocol on all of them. I'll run it on R1, R3 पे भी करना है. Network is 192.168.3.0. Network is 3.0.0.0. No auto. R4. Network is 4.0.0.0. No. PIX पे जब तक run नहीं करेंगे, it won't make a difference because PIX has to be the neighbor of everybody else. Network 10.0.0.0. Me with R2, R1. Network 192.168.3.0 with 3 192.168.4.0 with 4. So by the time this happens, neighbors should be up. They're not. They are. Message nahi dikhai. They are. So R1 has 1, 3, 4. Except for 2, he'll have everything. All of them will have everything. R1, R3 and R4. 1, 3 and 4. It's all shared. I enable NAT from here to here. What did I tell you yesterday? What happens when you do this? R1 loses communication. Inside loses communication to every other interface except for outside. Inside can only use outside. The moment you do this, the moment you enable NAT from inside and fix it to outside, inside loses communication to everywhere else. To DMZ3 as well as DMZ4. To do that, to let them talk, you'll have to create a separate rule. That is not NAT control. That is not NAT control. I'll explain what that is. I have this one loopback 1.1. Right? When he's trying to go out, will he be translated? Yes, because I said NAT inside 0, 0. Everyone who's coming from inside should be translated. Right? What if tomorrow what happens to my company? I get another IP, a public IP. I have a server inside here. I have a server inside here. Right here. This server has a public IP. I give it public IP not from outside, I give it public IP from the inside. Somewhere inside. So I'll give it say 111.1.1.10/24. This is a public IP. What I want is whenever this server is trying to go out, it should not be translated. It should not be translated. How do I do that? I showed it to you yesterday. How is that done? NAT 0. I did it using NAT 0. I said NAT inside 0 and then there's a difference. The one which I used, let's do it on the notepad. What I did until now was this. I said global outside 10, then the pool 11 to 20, and I said NAT inside, move it to 10, 0, 0. This 0, 0 here is which addresses to translate. Every address to translate to where? To this pool. Now, what I'll do is I'll say NAT inside 0. This is the pool place. This is where the pool is specified. In the pool I say 0. There is no pool as 0. 0 is a special keyword which says do not translate. Do not translate. Which one do I not want to translate? Exactly this guy. I do not want to translate this guy when he's going outside. Let's do that. Let's try this. Where on the pics? He says 111.111.1.1 will be identity translated when he goes outside. Let's check our NATing statements. This comes up. Why? Because more specific. It comes up in the list. So if this comes first he'll be given more chance. He won't be translated, right? It's just like an access list, one line at a time. Good. I have no loopback 111.11. I'll create it. I'll also advertise it where? In my EAGR. The problem right now though is when this 111 is going out, he'll go out as what source? 111. It won't be translated. But when it reaches R2, R2 does not know where 111 is. R2 does not know where 111 is. This is where NAT control comes into play. This is exactly where NAT control comes into play. Think about this. Think about this. When I told you that inside is connected to outside, at that time inside is not allowed to talk to R4. When inside is not allowed to talk to R4, what happens to the packet that inside sends out? He sends out a packet, he reaches the PIX. Where is it stopped? Is it stopped at the PIX or at R4? It's stopped at the PIX. When I send a packet, where's my... When I send a packet from here, this packet meant for DMZ. This is DMZ. DMZ4, this is DMZ3. A packet coming in, trying to go where? To the DMZ. When it reaches the PIX stops it. Why? Because there's no NAT rule for inside to DMZ. The PIX stops it. But if, say I have 1.1.1 here, 1.1. right? I have 1.1. Let's say I change my rule. Right now I'm doing what? Everyone from inside is translated, right? Now be careful when I'm doing this, alright? Show run nat. Whoa. There you go. I'm translating everybody, right? I won't translate everybody. I'll say nat from inside only 10, 11, 11, 0 should be translated. Forgot to give the pool name. Only 10, 0, 0 should be translated. Not no nat. What is wrong? Nat inside, move it on to 10. The inside should be 10, 11, 11, 0. Okay. So only 10, 11 should be translated onto 150.1. That's my condition. So when 10, 11 tries to go out, it's allowed to go out. Right? Show users, it'll be natted. What happens? Source loopback of 0. This loopback 0 is 1.1.1.1. 1.1, not 111. Leave 111 on the side, right? 1. Is it translated?
No, sir, no. Please stop that.
But I don't want you to know. See, I know it won't happen. But where is this packet stopped? That I want you to know. Where is this packet stopped? On the PIX or here?
R2.
It is dropped on R2. It's dropped on R2. Why? Because this guy tries to come in, goes to the PIX. There is no translation rule. So it moves out. Goes out where on? R2. But R2 does not know where 1.1 is. Why? Because it's a private address. It was privately done by R1. It's not public. Only public I purchased was this. This is private, so he doesn't know. The internet has a rule which says do not allow private addresses to come out. Right? This is like how NAT is used. This is not enforcing NAT. Enforcing NAT means NAT control. Remember those boxes that I drew yesterday? These boxes that you have here, ACL. Then you have SQ, right? Then you have the NAT. Until now, what used to happen was packet used to come in, get checked for ACL. There was no problem with the ACL. No problem with the ACL, so goes through. No problem with security level, goes through. Goes NAT, checks if there is NAT or not. If there is NAT, it's NATed. If there is not any NAT, doesn't NAT and go out. He still goes out. When you enable NAT control, the moment you enable NAT control, this NAT, this part here, is enforced. What do I mean by enforced? Now if a packet comes in, comes ACL, there is no ACL, goes out. Comes SQ, no SQ, that's fine, comes up. Comes to NAT. If NAT control is enabled and this packet is not getting translated at all, not about not getting translated, there is no rule for him. Is it getting translated or not? That's a different story. If there is no rule for him to get translated, NAT will drop him. This box will drop this packet. So this 1.1 that was trying to go out without getting translated right now will be stopped where now? On the PIX. For it to go out, there has to be a rule in the translation. There has to be a translation rule which can even say do not translate it. But as long as there is a rule which says something about it, it's alright. he'll let him go. But if there is no rule, is never allowed to go out. That's NAT control. Why? They removed it later. They thought it was useless. Why did they do that? Because see, if he tries to go out, he's going out as a private address. The internet was anyways going to block him. The internet was anyways going to block him because private addresses are not allowed on the internet. They have access lists for private addresses. They do block it automatically. Do you understand this? The difference between the earlier one and this one. There are two things. One is when you enable NAT. When you enable NAT or inside and outside, this inside is not allowed to talk to other DMZs or anywhere else unless you have a rule for them to talk. That has nothing to do with NAT control. Even when you do that, when this is enabled, inside to outside there is a ruling which says only 10.11 should be allowed to go out. But even at that time, if 1.1 tries to go out, his source will not be changed, but he will still be able to go to the internet. Then the internet will stop him. When you enable NAT control, when 1.1 is coming out, he sees there is no rule for 1.1. That NAT box will say there is no rule for you. I have NAT control enabled. Sorry, you cannot go out. It stops him. Does not let him go to the internet. Right? So now if I enable NAT control, 1.1 will be stopped where? On the PIX. Check out right now. When I was trying it, it's at least trying, right? Why? Because his packet is going out, it's not getting a reply back. So he's waiting for the packet to reply. There's no one telling him that this is not going to happen. But if I go to the PIX and say what? NAT control. Then try to do this again. Connection refused by the host. Which host? PIX. PIX is refusing your connection to go out. Is this clear? Any questions here? You understand the difference between the two? You understand the difference between the two? Now, the question I have is this loopback that I created. This needs to go outside untranslated. But now NAT control will stop him. This is a public address. If this is a public address, the internet also knows about it. Right? This is a public address, the internet knows about it. So it should have a root. Always miscall. IP route 111.111. No, I'm saying the internet. The internet has a route to this guy. Why? Because it's a public address. The internet, now it won't be exactly like this, but when you purchase an IP address and you tell the internet, hey, I'm keeping it behind my network, so they'll have a route through you to this one network. So that network will be reachable to the internet from 20.10, the firewall. So that when 111.111 comes out, R2 knows exactly where it is. It's a public address which you have purchased from the service provider. The problem right now though is 111 is trying to come out, but there is no NAT rule. So PIX is stopping him. For that we have a rule which I've just implemented, NAT 0. The rule is called NAT 0, which says do not translate this. But there is a rule for him. As long as there is a rule for 111, NAT control will tell him, alright, I've been told that you should be allowed to go out, so it lets him go out. So if I ping now, if I telnet now from R1, telnet 200.111 with the source, see loopback 0 does not work, it stopped, but loopback 111 works because there is a NAT rule, because NAT control is enabled. Is this clear? Show users, what will be the source address? 111.111. NAT control is not blocking. Why? If you check this, I have a rule for 111.11.11. 1 now. If there was not this, if this rule was not there, it would not be allowed to go out. You want to try? Let's remove this rule. Now 1.1 and 11.11 both are on equal grounds, right? Clear the X late. Connection refused. Connection refused. This is for what? 111. 1101 is refused. Even loopback 0 is refused. Who's stopping? NAT control. NAT control is stopping the packets coming out. See what's happening again. 111 is trying to go out. There is no rule for him. The only rule is for this network. So when this tries to go out, there is no rule. But NAT control is on. Since there is no rule, he blocks him, says no, please, cannot go out. I created a second rule earlier which said NAT 0, this network. So when it comes in here, he checks for the rules. The rule says, do not translate this, but there is a rule. So he says, alright, you should go out as 111. So it lets him go out. The internet knows where he is, he replies back. And the packet reaches. Right? NAT control. Then, this was NAT control using, NAT exemption. Do not NAT. There's also one more. We did static yesterday, right? Static command, static inside outside. You could also say, this is called NAT exemption. The other one is called, the difference is in identity NAT, you statically map inside to outside. Which address on the inside? I'll do the same address. No, the outside address first. This is the outside address. The inside address.
Command is static or dynamic?
Static. Statically bind the inside address to the outside address, but same. Same inside to the same outside. What do I mean by that? If I have this command enabled, this is identity NAT. This command is enabled. Now 1.1 is trying to go out. Right? I'll remove the other command. I'll remove NAT exemption. I'll have only this. So when 111 tries to come out, right? He checks, does he have a ruling? Yes, he has. On the inside, if it's 111, on the outside it should be also the same. So it does NAT him, but with its own address. It does remove 111, but he again puts same 111 back. That is identity NAT. Which one is better? It does the same thing as NAT exemption. Both do the exact same thing. But the good thing about NAT exemption is it exempts NAT, means it does not use the NAT engine at all. Here the NAT engine is used. Why? Because you remove and then you put it back in again. So that is less processor intensive. This is more processor intensive. Has more load. That one doesn't. Yes? But you have to be careful when you're asked to do something like this in the exam or something. You might be asked this question differently. 111 is trying to go out. Right? Prepare a ruling for him on PIX where 111 is not translated when it's going out. Which one will you use? It's not translated. Not translated means exemption. They may ask you, 111 should be able to go outside so that it is seen as his own address on the outside. That is identity NAT. So in this question, they might play around with the words. You have to know exactly what each does. What does NAT exemption do and what does identity NAT? Identity NAT is NATing on its own address. Exemption is no NATing at all, but you have a rule for it. Good enough? Good. That was static. That is NAT exemption. So we'll try this also. On the picks, our NAT control is on. I'll say no NAT exemption. Now I'll remove the no NATing command. It was removed anyways. Show run NAT. There's only one NAT happening. I'll say static inside outside 111.1.1.1 111.1.1.1. Right? Let's see if this can go out now. Can. Right? NAT it onto himself. You can see the NATings happening. Show static. Right here. Right? Onto himself. Identity NAT. Understand the difference. Then we come to the main topic for today, which is destination NAT. The main topic is destination दो दिन की कर लेना पूरी और आज की भी. Destination NAT is, what does destination NAT mean? Alright, this is the main topic for today because this has a lot of concepts, so try to understand it properly. Until now, whenever we used to do NAT, until now, this is my notepad. Until now, whenever I did NATing, how did I use the static command? I said static inside, outside. Then I said outside address is say 150.20.3, and inside I said say right now I'm doing it for let's change this. Right, and this is not inside. This is DMZ3. So I said 3.3 on the DMZ inside should be seen as 150.1.20.3 on the outside. Explain to me this then. If this is what I do, 3.3 is here, right? This is 3.3 right here. I'm representing him by 20.3, right? When the packet is coming from R3 to R2, what does it look like? R3 to R2. What does the packet look like? What is the source of the packet? No. 333. Is going to the internet at, this is the source, this is the destination, right? Now when it's going from where? 3 to this guy. When it hits the firewall, same packet when it hits the firewall here, what does the firewall do? Change the source or the destination? Change the source. So remember, the command is the same. I'm using only one command. Changes the source. The packet goes out. Goes out as what? The source is changed. Let's change the source first. The source becomes 20.3. Goes out to 200.1 as 150.1.20.3. 200 replies to whom? The reply from the server comes to how? What is the source? Destination? 150.1.20.3. This is the source, this is the destination. Be very, very careful here. Now this packet is coming back from what? The internet, hits the PIX. This time what does the PIX change? It changes this to 3 dot. Does the route look up and throws him in. How does this from the same command the PIX know that here I was supposed to change the source, here I changed the destination? How does PIX know? The command is the same. The command says inside DMZ to outside. How does he know coming back, when the packet is coming back in, I need to change the destination? How does he know when I'm going out, I need to change the source? The translation table is created for packet coming in, but packet is also going out. At that time, he's changing the source. Right? This is the rule. This right here is the rule. This is your rule, which says inside is 3.3, outside is 150.1.20.3. I'm not talking about that. I'm saying when the packet is coming back in, the packet is the normal packet. How does he know from that packet that I should change the destination? There's no access list is used to allow it to back in. That is when the person from outside does come in, the access list lets him come in. That's not the point. The point is, how does he know I'm supposed to change this? Why is he not changing this part? Connection table to maintain hui hoti hai na. I'm not talking about, say tomorrow someone else comes in from outside, he uses 150.1.20.3 as a source. At that time, will he change the source? Someone is coming from outside, he uses 150.1.20.3. He's coming and he hits which interface? This interface. Will PIX change the source at that time? There's no MAC address involved. This is layer 3. We're talking about layer 3. MAC address is done automatically here. Same port number. Here, there's no concept of port numbers again. It is the same like it was before. That's how it's coming back in.
So he will check for the destination for every packet for the source in address.
For source in? In?
For the source packet in address, he will check for all packets destination for that entry.
For the destination on that. What if a packet comes in from here then with the destination of 150.1.20.3? Yes? That won't work. You won't let him come back. What happens is this command has something also internally working. What do we mean by that? This part is called the source. This called is the destination. Now we know, you and I, we know that outside is mapped where? To this address. Sorry. Outside is marked to which address? This address. And this part is marked where? To this. Right? That's what we did. High, low, low, high. This DMZ was marked here. Outside was marked here. Outside address is this. Inside is this. When I say this, remember this. This is meant for source. This is meant for destination. What do we mean by that? What I mean by that is when a packet comes in, it hits the firewall on which interface? That is inside. DMZ, sorry. It hits the packet on DMZ. He checks his static command. DMZ here is where? The first. First belongs to, so he changes the source. He doesn't change the source, he checks the source for 3.3.3. If it is exactly matching this source, this part of the command, he flips it with this part of the command. The packet comes in, this packet comes in, 3.3 and 200.1, hits the PIX. He goes into his static command. Static command says source is here, destination is here, right? He says if the source, he always checks the source because DMZ, it hits on DMZ, right? So he checks the DMZ source. Is it 3.3.3? Is there 3.3 here? Yes. So it matches the command. He deletes it and replaces it by 150.1.20.3. Now when a packet is coming back in from the outside, which interface does it hit? Outside belongs to, he checks the destination of the packet. Is the destination what? 150.1.20.3. If it is, then he changes to, he flips it to 3.3. So it matters on which interface do you hit. Whatever interface, if you hit on the DMZ, source of the packet is checked. If you hit on the outside, destination of the packet will be checked. You understand? Questions?
If we DMZ code, if we are doing the same static DMZ code
To outside.
150.20.3 same IP and 4.4.4. So while coming, how it will identify its
Let's do that. Static, DMZ4, outside,
same IP.
150, not same IP. IP will be different, right? IP will be different. You cannot have same IP with two DMZs. Right? Set 20.4. How can you have same IP with two different addresses? So this will be 4.4.4.4. Right now outside is on two addresses. So we'll check both. See which one is matching. Right now which one is matching? 20.3, right? So we'll check first this is 20.4. No, it's not matching. Cancel. Go here. 20.3. It's matching. So changes it to 3.3. Yes? I'll do this again. On the paint. The diagram is the same. My diagram is the same. The thing is, my command is static DMZ3 to outside. Saying what? 20.3 is 3.3.3.3. The other command I have is also static DMZ4 to outside. The outside address is 20.4 and inside address is 4.4.4. Good? Say a packet now is coming from DMZ to outside, is going out. The source of the packet is, destination is 200.1.1. This is the source, this is the destination. Now this is trying to go out. So it goes out, hits what? The PIX. Goes and hits the PIX. The PIX checks what? His commands for NATing. Right? Which interface is it hitting on? DMZ3. It's hitting on DMZ3. So in his commands, which command does he check? He'll check all four. He won't check only this, only the source part. He'll check this, 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 and this. He's only hitting what? DMZ 3. What is the matching address of DMZ 3? 3.3. So we'll check, is DMZ 3, is this packet, whatever came in, is his, this is the source, right? Is his source 3.3? Is it? Is it 3.3? What is he going to flip it to? 151.20.3. So it will become 20.3. Then go out of the PIX from the outside interface. How does the packet go out? Simple. 150, 20.3 and this is the packet that is going out. Right? Then it goes out, reaches where? Wherever destination is coming out to. Then the return packet is created. This is now from the server. This is 200. Now he replies. What does the return packet look like? And destination is 20.3. Right? Packet hits what? The PIX. Which interface does it hit on? Outside interface. In his commands, he has two places where outside is written. He has two places where outside is written. So if he checks, say for example, he checks this first. Outside is mapped here. Is it? Does it have, this is destination, right? Is the destination of the packet 150.1.20.4? No, so he takes this out. This is not what he's looking for. How about this? It is. So he flips it where? Flips it to what address? Okay. Now this concept, why am I telling you this concept? Is because in destination NAT, this is how exactly you can understand. Otherwise it's very difficult to understand. If you understand this, we can move forward to destination NAT. We are only right now on half of it. We have not completed the full concept. This is the base. Do you understand this? Until now, how it works, right? Now, say what usually happens on the internet. What usually happens on the internet is, not usually, very few times, but sometimes it does happen. You have a company, the firewall is here, connected to a device. This is your server inside. And you have a device, this device. This is a very old device that you have. This is an IP device. The problem with this is it does not have a default gateway option. The address that it has is, say, 3.3. Yeah, it's a private address. On your inside, this is DMZ3. This is your outside. Now it doesn't have a default gateway option. What does that mean? This is .10. This is .3. This is, say, .1. What does that mean if it doesn't have a default gateway? It cannot go to outside this network. Cannot go out of this network. What is this network? 192.168.3. It cannot send a packet. This device cannot send a packet. It's not up to this. If the packet reached here, it would go to wherever it wanted to go. But this device does not have the capability of sending out a packet to any other network other than 192.168.3. Right? It happens. There are some devices like that out there. Old devices, but sometimes you might need them to communicate. Your job in this case is, this is the internet, right? This is the internet, right? There's a server somewhere out on the internet. There's a server out there on the internet. Your job is to update this using that server. But it does not have a default gateway option. The problem is there is no default gateway. The objective is for this device to talk to this server out there. Problem is, it's very simple. How do you make that happen? First things first. First things first. If it was possible for him to go out, I'd be using a normal static command which said static DMZ3 to outside. DMZ3 to outside, saying the outside address is whatever address you wanted to give it. To this guy on the outside, say 33. So outside I would say it's 33, and inside address is 3.3. That means when he's going, if he was about to go out, his source will be changed to 150.1.20.3. So on 200.1, who's talking? 20.3. Is it possible, just like we represented this as something else on the outside, is it possible to represent this 200.1.1.1 as a private network on the inside? Is it possible to do that? See, right now, until now, what I did, I showed you that source and destination problem, right? I showed you how we change the source and how we change the destination. What if I have another command here which says static outside to DMZ3. It said outside to DMZ3, which checks if the outside address is 200.1.1. Sorry, not here. Which checks if, this is here, outside is here, right? That's right. Outside is here, right? Mapped to this. Then on the DMZ, it should be seen as, say, 150.20 dot a random address. Just like this 192.168.3.3 had a random address on the outside. I'll represent this by a random address here. Not 150.1. This is wrong. This is totally wrong. Private address. 192.168.3 dot. Is it possible to do something like that? With this command, I represented 192.168.3.3 as 150.1.20.3 on the outside. If I do this, is it possible that this on the outside can be represented as this on the inside? That means here I'll have this will be just an IP, just a floating IP. So when this pings 192.168.3.200, where should the packet go? It should go here. Let's have a look at this. Let's see if this actually works. Using the same concept like we used in the previous one. How does the packet look like? 192.168.3.3 going to .3.200. This packet is generated by this device right here, which does not have a default gateway. Packet goes out, hits the firewall. Firewall has these rules. Remember? Which interface am I hitting on? This is the DMZ3, right? Is there a ruling for DMZ3? Here it is. What does he check? Here checks the source, because DMZ is in the first octet. So checks the source. Source checks for what? This 3.3. Is it 3.3? Changes 3.3, makes it 20.3. He also checks this. DMZ3 is also there. It's not only in source, it's also in. With this, he checks the destination. Is the destination 192.168 3.200?
Yes.
Is it 3.200? Here, it is 3.200. Of the same packet, you have two commands. He checks both. He doesn't only check one, he checks the other one also. It is 3.200. What does it flip it with?
200.
Does the route look up? Throws the packet out. Here, look at how the packet looks like. So I'm not only changing the source, I'm also changing the destination. This is what's called destination. Changing the source as well as the destination. The commands are not important. This is all you have to do to implement this. That's all you have to do. But understand the concept behind. You understand the concept? Again, think about this first. Again,
200 will remain in PIX itself.
3.200 is just there. It's not an IP. Just like 150.1.20.3 is not assigned to anybody else. 20.33. It's also on the PIX, right?
So
Let me do this clearly.
Just a pool kind of thing that
Just like a
created
pool.
for 90.
Yes. Just like a pool. Let me do this again neatly now.
What kind of scenario would we particularly try to reach a server outside of it?
Say you want to update the databases on that server for this. So you can't do it directly, right? So you'll have to connect to the internet, but he can't go everywhere on the internet.
Yes.
You can go to that one server. I have, the command is static, not inside, DMZ3 to the outside address is 20.33. The inside address is dot 3.3. The other command that I used was outside to DMZ3. What is the outside corresponding address here? I'll write it here. I want to represent 200.1.1.1. I want to represent this 200.1.1.1 as a new address on the inside, which is 3.200. This is my PIX. This is the device is right here, right? This is dot 3. This is the address which I want to translate, and on the outside this is the server which is it's connected to the internet, right? So it's connected to R2 first. On R2 is 200.1.1. Right? And 3.3 is here. This is dot 10. This is a device which cannot communicate anywhere else. But I configured these commands on the PIX, and I asked him, alright, if you want to update your database, you go where? Which address? Three dot 200. I tell the device, you ping, not ping basically, just go to this device for your updates. 192.168 3.200. He says okay. Alright. So he starts sending a packet to 3.2. It's just a pool IP. This 3.200 is a pool ID. So the ping that he says, the device, the packet looks like this. The source is 3.3. Destination is what? 3.200. 3.200 does not exist anywhere. Does not exist anywhere. It's just like a pool. This packet, although, so this is my packet, right? It's coming out from here, goes where? To the PIX, because he's the one responsible for this address. PIX now needs to check these two statements. What do they say? The same concept of source and destination. Checks DMZ3 is here, so at the source, he needs to check the source of the packet. Checks the source of the packet, 192.168.3.3. Does it correspond to this source? So he needs to flip it where? 150.1. The new source becomes. Checks the second command. 20.33. Checks the second command. DMZ3. It's hit on DMZ3, right? So it's also on the destination part. Checks the address corresponding to the, because it's a separate command, so the address will be different. Right? What is the address corresponding to the DMZ? The destination part is 192.168.3.200. Is it 3.200 in the destination of the packet? It is 3.200 in the destination of the packet. Flips it to what? 200. 1.1. So your packet looks like this. Goes out to 200.1. This is the packet going out. Let's have a look at the packet when it's coming back in from 200 now. How will the packet look like? How does the packet look like? What is the source? Destination? 150.1.20.33 is the destination, right? The packet goes in, hits what? The PIX. Hits the PIX. Now tell me, what is a check? First command. Which interface am I hitting? Outside. Remember, this is source always, this is the destination. This is how the command is programmed. Always. Right? So now packet comes in, hits this interface. Which interface? Outside interface. First command, what does it check? What should the destination be? 20.33. Is it 20.33? What does it change it to? 192. The destination part it changes to 3. Normally he would do this and let him go, but there's also another command he needs to check. Does it match somewhere here? Which part? Outside is on the source. What does he check on the source? Source is here. What does he check on the source? It should be what? The source should be 200.1.1. Then only can he execute this command. Is it 200.1?
Yes.
It is 200.1. So he changes it to what? 3 dot. Changes it to 192.168.3 dot. And the packet goes where? 3.3. This source, this destination. So for this device, it feels like it's talking to whom? 3.200. But it's actually talking where? Outside. Any questions?
But the device has to ping, always ping.
Point ping any packet, whatever he sends. Doesn't have to be a ping. Whatever packet, natting will go through. Natting will always happen. Any questions? Any way you didn't understand? Any part you didn't understand? This is one of the most important topics. See, this can be taught easily like with these two commands. You do this, destination NAT. Now why this is good? Because it actually shows you the concept of how this command works, how the static command works, how it's actually used. Clear? Good? Move forward? Everybody. Let's go. That finishes your, but we'll do this. We'll also do this. We won't finish it just like it is. You can actually paste this. Now see, do the diagrams. This is right. What I want to do is this. This is 3.3. I'll do the same exact thing. 201 on the outside, 3.3 on the inside, and dot 200 should be represented so I can talk. Right. First things first, I'll remove the previous NAT. Clear configure static. Clear configure NAT, and also global. I'll clear all. Then I'll say static DMZ what? 3 to outside. On the outside, the address is 151.20.33. On the inside, the address is 3.3. Right? And static outside to DMZ3. Outside to DMZ3. Now inside address for this should be 3.200. The outside address should be 200.1, which is on the outside should be seen as 192.168, 3.200 on the inside. That's all, just two commands. Let's see if this works. R3. I'll do one thing, I'll remove the default gateway to make it more realistic. R3 is not capable of having a default gateway. 3.10. Also, no router yet. So the only thing that has is 192.168.3. I will also remove the loopback. Only one connected interface, that's the only interface it can talk on. Let's try. Telnet. किस पे? ऐसे पे. I'll telnet what? Not from here. Telnet which address?
200.1.2.
Cannot 200. There is no 200 available to me. What do I telnet? I cannot go outside one. I cannot go to those networks. If I do that, it says no route. What do I do then? 3.200. 200.111 on the outside is represented as what on the inside? 192.168, 3.200. So I should ping 3.200. That will be then my packet will be converted to the one which we were doing until now. I will take time because he is supposed to do both source as well as destination. Done. Cisco. What will my source be?
3.33.
3.2.20.33. 150.1.20.33. So the internet sees me as a public address. but actually I'm a device who can't even talk to my default gateway properly. Right? So I'm actually pinging that floating address which is not there, but it's actually 200 represented on the inside. Alright? Now if this guy wants to talk to this device, how does he talk? 200. Which address does he go on? What is the telnet? This is the internet. It doesn't have 192.168.
Source to
It'll telnet to 150, 150.1.20.33 with a source loop back of. Now it won't work. Why? It won't work. Why? Why will this not work?
Connection table is lower to
I need to create an access list. I'm going from high to low to high. Low to high. So I need to create an access list. Oh yeah, there you go. It doesn't show the natting part. But yeah, the addresses are there. 200.1 and 20.33. Build outbound connection 40 for outside 200.1, which is on the inside what? To DMZ, which is this and this. There you go. This is the line. Outside is 200.1.1.1, but the address corresponding to him is 192.168 3.200. Then inside is 192.168 3.3. The address corresponding to him on the outside is 150.1.20.30. Make sure you understand this properly. This is all of NATing. This is the only difficult concept in NATing. Everything else you have done before. This is the new one. Good. So now, if this is good, then I need to create that access list. Access list INF permit, right? IP, or I can just say TCP. From what source to what destination? That is my question.
source will be
Source will be host to 20.33. Then access list INF in interface access group INF in interface. Done. So now R2 should be able to go in using source loop back 0. It's open not set. Why? Because I have not set up the done. Let's try. What will my source be?
150. Sorry, 200.
What is my source going to be?
192.168
My source will be 192.168 3.200. Remember, 3.3 is not talking to 200.1 for him. On the inside, it's talking to 3.200. It's not talking to 200.1, it's talking to 3.200. Right? On the outside, though, on the outside, this guy is talking to 150.1.20.33. On the inside, R3 is talking to 3.200. That is the difference between the two. Do you get this? Do you really get this? Yes? If you want, I'll repeat it. No? Clear? Repeat it. See. What was my commands? These are my two static commands. Right? What do my static commands say? It says static DMZ outside. There's two commands, static DMZ outside and static outside to DMZ. This was normal. When I used to do this, this was my normal command. This is known as source NAT. Why? Because for me, I'm 192.168.3.3. When 3.3 is going outside, his source is always changed. His source is changed to 150, a public address on the outside. Right? Whenever this 3.3 was trying to go outside, usually his source was always changed. So that was source NAT. Now the problem is on that packet, whatever packet is going out, the source was getting changed. The problem right now is, see, this does not happen in real life usually. It happens like 0.5% of the time. You'll have to do something like this. But it's good to know how to do this. How does the command actually work? Now see, this is going out, right? The source is 192.168.3.3. The destination is what? The destination is usually used to be 200.1. Usually. So that was possible because he knew where 200.1 is, so he used to give it to the default gateway. This guy used to send it out. The problem right now is this guy cannot send a packet to 200.1. He can only send a packet in this network. 192.168.3.0. That was the problem. So what we did was we said, okay, we'll create a floating IP which will be 3.200. We said we'll have this 3.200 here, which will be represented by the firewall. So whenever this 3.3 is going to send a packet to 3.200, the packet is going to look like this, with 3.3 as the source and 3.200 as the destination. Hits what? The firewall. What is our main aim? Our main aim was this guy talk to this guy, the outside. So it won't just work if I change the source. If I only change the source, this packet will get dropped because there is no such thing as 3.200. There is no such thing as 3. I am mapping my source to outside. I am mapping this. I am mapping this part. 3.3 as 150.1.20.33 on the outside. I am mapping this part, but I also need to map this now. So when the packet goes out, my source is changed. My destination should not remain 3.200 though. My destination of the packet should become 200.1. So I'm not only changing the source of my packet, I am also changing the destination of my packet. Work on the packet level, everything is happening to that packet that is hitting the interface. To that packet, I'm changing the source as well as the destination. So it reaches here, I remove this, put in 200.1. I remove this, I put in 150.1.20.33. Right? The packet goes, reaches the destination. The return packet comes like this from 200 going to 150.1.20.33. Packet comes back, hits the firewall. Now most generally what it used to do was used to change this to 192.168.3.3 and forward it. He can do that, but the problem is R3 will not understand what 200.1 is. So here he needs to change both this source as well as this destination again. That is exactly why I need two commands, one to change the source, one to change the destination. And that is why I have DMZ first as the source, also as the destination. This is for outgoing. For incoming, I have outside as the destination as well as the source. So when it hits the outside, here the source is changed, here the destination is changed. When it hits the DMZ, the source is changed and destination is changed. I told you source and destination, right? The first is the source, the second is the destination. So I'll have DMZ both in the source as well as in the destination. I'll have outside both in the source as well as in the destination. The packet hits, both of the things are taken out. Source is also removed, the destination is also removed, a new value is put in. When it's going out as well as when it's coming back. Alright? Good? That is destination NAT. Where's the file? That is your destination NAT and static NAT we have done. So what we're left with is these three: static PAT, policy NAT, and DNS doctrine. These two are easy. This one is a little. It's not. It's just one command. It's just one command. Just one little command. Not even a command. It's just a word. One little word. But the concept is a little. Again, I can just tell you the word and you'll be done with the topic. But we'll understand what it does. What that one command does. DNS doctrine. Right. We'll take a break. It's 3:40. So be back by 4 o'clock. 4 o'clock. Yeah, alright, yeah, it won't take 9. 4:10 is enough. 4:10 is fine.